I want you to just take a second right now and look at the things around you. Like maybe it's the phone in your hand, the shoes on your feet, or just the laptop sitting on your desk.
Yeah, we really take all that for granted.
We totally do. We rarely think about the invisible web that brings almost everything we own right to our doorsteps. It's this massive silent choreography of metal and water. But beneath the surface, that global shipping industry, the actual physical backbone of human trade, is undergoing this massive, largely unnoticed revolution.
And, I mean, the stakes here honestly couldn't be higher. We're looking at an industry that's responsible for nearly 3% of all global greenhouse gas emissions.
Which sounds small, right?
Right. 3% might sound manageable in isolation, but on a planetary scale, it is just colossal. So any shift in how this invisible web operates, it carries massive planetary implications. The traditional model of moving goods across oceans is basically hitting a wall, environmentally, economically, all of it. And the major players are just being forced to adapt or, well, face systemic failure.
And that adaptation is our mission for this deep dive.
Yeah.
We are looking at a huge stack of recent sources detailing the operations of COSCO Shipping, which is one of the world's absolute largest logistics and port operators. Our goal today is to cut right through the corporate jargon, all those dense sustainability reports and maritime news updates, to reveal how the actual backbone of global trade is rewiring itself.
Rewiring with AI, blockchain, alternative fuels. It's a lot.
It is a lot. So, okay, let's unpack this, because to even grasp the transition, we first have to understand the sheer mind-boggling scale of what we are dealing with here.
Scale really dictates everything in this industry. I mean, looking at COSCO's 2025 data, we see an operating revenue of over 219.5 billion RMB.
Wow.
Yeah, and they're managing a fleet of 590 ships. And those ships have a capacity of nearly 3.6 million TEU.
And TEU, that stands for 20-foot equivalent units, right? Which is basically just your standard shipping container.
Exactly, the standard metal box you see on trucks. And on top of that fleet, they operate 40 ports globally, overseeing nearly 400 berths.
590 massive ships just moving constantly. It's almost too big to hold in your head. But before we even get into how they are physically powering those ships differently, we first need to look at how they are upgrading the system's brain, like the digital transformation. Because moving thousands of tons of steel across an ocean is crazy expensive, and doing it inefficiently is just a catastrophic waste of capital and, frankly, carbon.
Right, and historically, global logistics has been completely handcuffed by paper. Just mountains of it. You have customs declarations, bills of lading, international handoffs.
I read about the bills of lading. That's like the most important document, right?
It is. A bill of lading is basically the ultimate legal receipt and title for the cargo. When a ship arrived at a port in the past, if the physical paper document hadn't caught up via some courier, the cargo literally couldn't be released.
So they just sat there.
It just sat there. Ships would idle, containers sat taking up space in the yards, and trucks waited in these miles-long lines. And obviously, all of that waiting burns fuel.
So the sources highlight this huge shift away from that physical paper trail with something they call the IQAX EBL, which is a blockchain electronic bill of lading. And the numbers are wild. They issued 450,000 of these electronic documents in the reporting period, and the result is staggering. They compressed document transfer times from taking literal weeks down to hours.
Yeah, the speed is an incredible operational advantage, but the underlying mechanism, the blockchain itself, is really what makes it viable in the real world. By using a decentralized ledger, they securely share this digital truth across the entire supply chain.
Because nobody trusts anybody in global trade.
Exactly. It eliminates the need for trust between competing entities.
Right.
Because the mathematics of the blockchain basically guarantee that the document hasn't been altered or forged by anyone.
And if you're listening to this, it's wild to realize that the digitalization doesn't just stop at the paperwork. They are applying AI to the physical movement of the steel boxes themselves. There is an AI empty container routing system they've deployed, and it uses something called graph neural networks.
Which is fascinating tech.
It really is. From what I understand, a graph neural network essentially visualizes the entire global supply chain, like a giant multi-dimensional subway map. It treats the ports as the stations, or nodes, and the shipping lanes as the tracks, or edges. So instead of, some human looking at a massive spreadsheet and guessing where boxes are needed, this AI can actually see the cascading ripple effects.
Right, because moving an empty container across the ocean generates absolute zero revenue for a shipping company. None. but it still burns heavy fuel oil.
Right. So the AI identifies where empty containers are sitting around globally, predicts a surge in demand at a factory maybe weeks in advance, and autonomously redirects those empty boxes to where they will be needed next.
And by using that predictive modeling to anticipate demand, they drastically reduce those empty miles. But that intelligence also extends to the physical operations of the ports themselves. Like take the Wuhan Yangluo port. They've implemented what they call a 151 framework.
Yeah, I was reading about that 151 framework. I have to assume the One Brain is some sort of central AI command center. But how do the five systems actually execute those commands on a physical dock? I mean, we're talking about multi-ton cranes and massive trucks here.
Well, the central brain calculates the optimal flow of traffic, sure, but it needs effectors. So those five systems, they translate the digital commands into physical reality.
Okay, what are the five?
They cover smart gates that scan and clear trucks without them even stopping, then smart yards that stack containers automatically based on their pickup times. There's intelligent dispatching for the internal truck fleet, automated tallying of inventory, and finally, smart production control.
And then the final one in the 151.
That's the digital chassis. So the underlying infrastructure making it all possible, widespread 5G networks, cloud computing, and thousands of IoT sensors on the equipment itself.
And they are taking this even further over in Peru, right, at the Shinsei port. They are using a digital twin. Now, wait. A digital twin sounds like a fancy way of saying a video game simulation, but it's much more tied to the real world than that, isn't it?
Oh, it is entirely tied to the physical world. A digital twin isn't just a static 3D model, like a CAD drawing. It is fed continuously by those thousands of physical IoT sensors on the real cranes, the real power grid, and the real trucks. The virtual port actually breathes in real time with the physical one.
That's crazy.
It is. And it allows them to simulate and optimize energy consumption dynamically. So they can introduce a new resource scheduling plan in the virtual world, observe if it causes a bottleneck or wastes electricity, and then adjust it before a single real-world crane even powers on.
That is incredible. And this digital routing, it isn't just about moving containers within a port. It's about redrawing the physical map of global trade. I mean, the Zhenghe Sea Rail intermodal train they launched in 2025, that just blew my mind.
Yeah, that's a massive shift.
It moves cargo from Kunming straight to the Indian Ocean. It completely bypasses the Malacca Strait. By avoiding that highly congested waterway entirely, they cut the transit time by 17 days. 17 days. That is a 50% increase in efficiency.
Integrating sea, road, and rail into a single, seamless digital network, what they literally call a one-box-to-the-end system, it allows them to bypass those historical geographic bottlenecks entirely. It shifts the entire flow of global commerce away from traditional maritime choke points.
It's like upgrading the world's nervous system from dial-up to a fiber optic network. Everything is suddenly talking to everything else, perfectly optimized. But I do have to push back here for a second.
Go for it.
If you digitize absolutely everything, if you rely entirely on graph neural networks to route your containers and digital twins to run your cranes and blockchain for your legal documents, doesn't that create massive vulnerabilities? I mean, if a system goes down or gets hacked, doesn't the entire global supply chain just freeze?
Well, what's fascinating here is how the architecture of these new systems actually mitigates those traditional digital risks. Take the blockchain bill of lading we discussed earlier.
Because it's decentralized.
Exactly. Because it is decentralized, there is no single server a hacker can target to delete the records. It is fundamentally harder to tamper with than a centralized database. And in their governance structure, COSCO explicitly identifies data security and customer privacy as top materiality issues, meaning they view them as absolutely core to their survival.
Right, so they're not just treating it as an IT problem.
No, they conduct rigorous internal audits focusing on system resilience. The digital risk profile is certainly different now, but the decentralized tools they are building are designed to be far more resilient than the analog systems they are replacing.
Okay, so the system is smarter, but also more durable by design. I get that. But let's pivot a bit, because digital efficiency is great, but eventually you do have to burn fuel to physically push thousands of tons of steel across the ocean.
You can't digitize physics, unfortunately.
Exactly. How does a company with 590 massive ships actually pivot away from heavy fossil fuels? This isn't just swapping your gas-guzzling car for a hybrid. This is like trying to change the engines on a massive airplane while it's in mid-flight.
It really is. The physics of moving maritime freight present a uniquely difficult engineering challenge. You simply can't just scale up an electric car battery for a container ship.
Because it would just sink.
Basically. The battery required across the Pacific would be so heavy that the ship wouldn't be able to carry any actual cargo. This is why COSCO Heavy Transport has framed their transition not as a single quick fix, but as a three-step decarbonization plan based on what the technology currently allows.
Okay, what's step one?
Step 1 ran from 2021 to 2025, and it focused entirely on maximizing the efficiency of traditional engines and exploring initial hybrid systems.
Basically squeezing every possible ounce of efficiency out of the existing hardware.
Exactly. Then Step 2, running from 2025 to 2030, introduces battery power, but strictly for short-haul coastal routes, where that weight penalty is manageable. It also involved optimizing hull designs to reduce drag in the water and exploring onboard carbon capture. They are literally designing new ships with empty physical space reserved in the hull so they can install carbon capture machinery once the tech matures.
Oh, wow. Future-proofing the literal steel. And step three is the moonshot, right?
Yeah. Step 3 spans from 2030 to 2050 and tackles the deep sea challenge. This forces the industry into the massive, very difficult infrastructure challenge of using alternative fuels like hydrogen and ammonia.
Which are totally different to handle.
Completely. These fuels can provide the energy density needed for transoceanic voyages without the carbon emissions, but they require entirely new types of engine architectures and, crucially, global refueling networks.
So let's talk about where they are right now, looking at their 2025 stats. Because the transition is physically underway today. They consumed over 417,000 tons of biofuel in 2025, including B24 and B30 blends. But as a result of all this, their consumption of traditional heavy fuel oil dropped by 0.4% compared to the previous year.
Which I know sounds small.
I mean, wait a minute, dropping heavy fuel by 0.4%, that honestly sounds like a total rounding error. If you're listening to this, you're probably thinking the same thing. Are we just celebrating a drop in the bucket here? Is that actually a meaningful metric?
It sounds microscopic, I totally agree, but we have to contextualize it within the sheer scale of global shipping. When a single fleet burns millions of tons of fuel annually, a 0.4% absolute reduction, while they're simultaneously growing their overall cargo volume and expanding their fleet, indicates that the decoupling of growth from emissions has officially started.
Oh, I see. They grew the business but shrank the emissions.
Yes. The curve is bending, and the future trajectory is very clear when you look at their new shipbuilding orders. They currently operate 39 methanol dual-fuel container ships, representing nearly 730,000 TEU in capacity. Methanol burns much cleaner than heavy fuel oil and serves as a really vital stepping stone toward that zero-carbon horizon.
That makes sense. Actually, one specific vessel really stood out to me in the sources, the SEIN-KOU. It's a semi-submersible ship, but it's designed specifically as an eco-friendly vessel. It has optimized hull forms, but what caught my eye was its use of low-voltage SCR systems.
Ah, yes, the SCRs.
Yeah, I was looking into this. SCR stands for selective catalytic reduction. Instead of just trapping pollution in a filter like a car might, it actually injects a liquid reductant, usually something like urea, directly into the ship's massive exhaust stream. This triggers a chemical reaction that breaks down the harmful nitrogen oxide smog into completely harmless nitrogen gas and water vapor before it even leaves the smokestack.
It is a remarkable piece of chemical engineering on the open ocean. And if we connect this to the broader landscape, this physical transition isn't happening just because shipping companies suddenly decided to be environmentally conscious.
No, of course not. It's regulations.
The regulatory landscape is aggressively tightening. You have international frameworks like Fuel EU Maritime and the EU's emissions trading system, the ETS. These regulations literally put a price tag on pollution. They are forcing shipping giants to account for every single ton of carbon they emit in European waters.
Which means they need massive data.
Exactly. COSCO has had to build complex, smart analysis platforms to continuously calculate their emissions in real time. They aren't just tracking carbon for fun, they are quantifying the financial impact of climate risks. They are constantly weighing the rising cost of carbon taxes against the premium price of green fuels.
It's just a massive multivariable equation they're trying to balance every single day. Which actually brings us to the third piece of this puzzle. To fund these multi-billion-dollar green transitions, the financial structure of the company has to fundamentally change. And here's where it gets really interesting.
Green finance side of things.
Yeah. In 2025, COSCO Shipping Ports launched a green finance framework. If you're listening to this and wondering why a multi-billion-dollar company needs a green bond, well, It's because retrofitting a massive ship or building a zero-emissions port costs hundreds of millions of dollars, and traditional corporate loans often just don't account for the long-term environmental payoff.
Right, traditional finance models are simply not built for planetary sustainability. They just look at quarterly returns.
Yeah.
The Green Finance Framework allows them to fund eligible green projects specifically through targeted green bonds and green loans. It creates a dedicated pipeline of capital strictly for decarbonization.
But this is where my skepticism kicks in again. Green bonds sound fantastic on paper, invest in us, we're building eco-friendly ports. But how do we, or the investors, actually know this isn't just corporate box checking? Greenwashing is everywhere right now. How do we know the money is actually paying for the chemical engineering on the XCOU and not just funding their standard polluting diesel operations?
It is arguably the most critical question in modern corporate finance. And the answer lies in strict third-party verification. COSCO's framework isn't just an internal PR document they drafted up. It was rigorously validated by the Hong Kong Quality Assurance Agency, the HKQAA, with the Bank of China acting as their advisor.
Okay, so external auditors are involved.
Heavily involved. The framework aligns entirely with global green loan principles and green bond principles. This means that the money is legally fenced off. The use of proceeds is heavily regulated. They must prove, with auditable independent metrics, that the funds are going toward projects that genuinely enhance environmental benefits.
So if they cheat.
If they use a green bond to buy standard diesel fuel, they are in breach of contract. It enforces actual, legally binding accountability, not just good vibes.
Okay, so the money is tracked and fenced off. But let's talk about the people tracking it and the people actually out there on the oceans executing all of this. Because the human element in these reports is actually quite striking.
It really is.
In 2025, COSCO maintained a zero work fatality rate across their entire global operation, which is huge for heavy industry. And even more surprisingly, they reported zero pirate or armed attacks on their ships globally.
Maintaining zero pirate attacks across a fleet of 590 ships, navigating some of the world's most complex and dangerous waterways like the Gulf of Guinea or the Horn of Africa is a staggering operational achievement.
Yeah, that takes serious work.
It requires intense coordination, advanced threat monitoring, and highly trained crews. But, their focus on the human element goes well beyond just physical survival.
I saw that. They recently released a joint initiative on seafarers' well-being because the psychological toll of being a seafarer, stuck on a floating piece of metal for months, totally away from your family, that has to be immense.
The isolation is profound. And this initiative, which they actually launched in partnership with other maritime leaders, includes 8 major focus areas. It covers full-cycle health management, but more importantly, it deeply addresses psychological and mental health protection.
Like giving them better internet access.
Yes, exactly. They are working on optimizing the work-life balance for crews while at sea, improving onboard internet connectivity so they can actually reach their families, and building an industry-wide mutual assistance ecosystem. They recognize that you just cannot run a resilient global supply chain if the human beings operating the vessels are burning out.
And it seems their operational definition of sustainability extends even beyond the ships and the docks. They've integrated a huge social responsibility component into their corporate structure, too.
Right, the community impact.
Yeah, the 2025 data shows they invested over 30.9 million RMB into rural revitalization and charity projects. They are actively utilizing their massive logistics network to lower shipping costs in remote rural areas, which actively helps local farmers and small businesses integrate into the global market.
This really raises a fundamental question about how we define a sustainable corporation in the 21st century. It cannot simply be about counting carbon molecules in a vacuum. True sustainability means ensuring the communities that interact with your supply chain, whether they are seafarers navigating the high seas or farmers in a rural province trying to export their goods, are actually benefiting from your operations.
It's an ecosystem approach.
Exactly. They also enforce strict supply chain codes of conduct, auditing their own suppliers to ensure social responsibility compliance. It's a holistic, systemic approach to governance.
So what does this all mean for us? The next time you order something from overseas, and that package lands on your welcome mat, I want you to picture the journey differently. Don't just picture a rusty cargo ship slowly chugging across the ocean. Picture the graph neural network that predicted where the empty container needed to be weeks in advance.
Picture the decentralized blockchain system that instantly secured the legal ownership of your item across 3 international borders without a single piece of paper.
Yes. Picture the biofuel and the chemical reductants pushing that colossal steel structure across the ocean, and the seafarer monitoring the real-time, breathing digital twin of the port they are about to dock in.
It is a fundamentally different industry than it was even 5 years ago. The invisible web is becoming hyper-intelligent.
It really is, but it leaves me with one final kind of wild thought to chew on.
Uh-oh.
We've talked about how these ships are becoming heavily digitized, running on predictive AI, and preparing for next-generation fuels like hydrogen or green ammonia.
Right.
But as global shipping becomes highly automated and heavily digitized and fueled by these alternatives instead of oil, how will this shift global geopolitical power? I mean, think about it. If nations no longer rely on oil choke points or highly vulnerable physical trade routes like the Malacca Strait, thanks to direct rail sea links like that Yi-Chih train we talked about, will the entire map of global superpowers be redrawn simply by supply chain logistics?
That is, wow. It's the ultimate paradox of efficiency. We are solving the physics and the fuel problem, but we might accidentally rewrite global power dynamics in the process. We're just beginning to uncover the human and geopolitical consequences of all this.
Thank you for joining us on this deep dive. Keep questioning the invisible systems around you, because as we've seen today, they are never as simple as they look.